Hello, everybody. Welcome to a smart grasp, explore, and win. Greetings for the day. Let's get started with today's topic.
Class 6, Chapter 3, Playing with Numbers, Exercise 3.6. In that first sum, find the HCF of the following numbers. So they have given certain numbers for which we are supposed to calculate the highest common factor. There are various methods to find HCF. Now let's solve it using prime factorization method, which is most commonly used. So let's take 18. 2 nines are, 3 threes are, again 3 ones are. So the condition is we are supposed to divide it until we get 1, and the numbers we are dividing by writing here the sides, it should be prime numbers only. Next 48, 2 24s are, again 2, and next 3 8s are, 2 4s are, 2 2s are, finally 2 1s are. So till we get 1, we are supposed to divide it like this. Also, the main important rule is you are supposed to use only the prime numbers to divide. In this method, actually we are dividing it repeatedly. For example, first we are dividing the 48 by 2. 2 is a prime number. So we will get 24 as the quotient. 2 24s are 48. Again, we are dividing the 24 with the value 3, which is a prime number. So we will be having 8 as the quotient. So it goes on in that fashion. Now let's write the factors of it. 18 equal to 2 into 3 into 3 into 1. Next for 48, 2 into 3 into 2 into 2 into 2 into 1. Now let's circle the common factor in order to find the HCF. So we have 1 2 here, 1 2 here, 1 3 here, 1 3 here, and we don't find anything common. We have 1 here, 1 here. So the HCF will be 2 into 3 into 1. HCF is nothing but highest common factor. So we will be finding the common factors and we will be multiplying it to find the highest common factors. So for a pair, you are supposed to write one value. That is 2 is common in both 18 and 48. So for both the 2's, we will write 1 2. For both the 3's, we will write 1 3. And for both the 1's, we will write 1. 2 into 3 into 1 is 6. Therefore, HCF of 18 and 48 is 6. Now B sum. 3 tens are 30, 5 twos are 10, 2 ones are. Now for 42, let's start with 3. 3 14s are, 7 twos are, and 2 ones are. So for 30, we have 3 into 5 into 2 into 1. And for 42, we have 3 into 7 into 2 into 1. Now let's circle the common factors. We have 3, 2, and 1. Therefore, HCF equal to 3 into 2 into 1, which is 3 into 2 into 1 is 6. Therefore, HCF is 6. Now see sum. 18. For 18, we have already solved in the first subdivision. So the same, I'm just copying it here again. We can even start with value 3. So it goes like 3, 6 or 18. Anyways, the final answer will be same. I'm just starting it with 2 itself. And for 60, I can start with 2 table or 3 or even with 5. I prefer 5 table. Higher the value, shorter the division. If I start with 2, this prime factorization will be longer. No matter, the answer is same, but to keep it short, I am going to start with 5, which is also a prime number. 5 12s are 60, 3 4s are 12, 2 2s are 4, and finally 2 1s are 2. Now let's write the factors of both the values. 18 equal to 2 into 3 into 3 into 1 for 60. 5 into 3 into 2 into 2 into 1. So let's circle the common. 3, 3, 2, 2, 1, 1. Therefore, HCF equal to 3 into 2 into 1. 3 2s are 6, 6 1s are 6. And D sum we have 27 and 63. So let's start with 27. 3 9s are, 3 3s are, 3 1s are. For 63, 7 9s are, 3 3s are, again 3 1s are. For 63, even I can start with 3. As I already said, higher the prime number value, shorter the prime factorization. Hence, I have started with 7. So for 27, we have 3 into 3 into 3 into 1. And for 63, we have 7 into 3 into 3 into 1. Now let's circle the common factors. 3, 3, another 3 and 3, then 1 and 1. Therefore, HCF equal to 3 into 3 into 1, which is equal to 9. Moving on to next subdivision, 36, 84. 36, let's start with 3. 3 12s are, 3 4s are, 2 2s are, 2 2s are, and 2 1s are. For 84, 7 12s are, 3 4s are, 2 2s are, and 2 1s are. Now let's write the common factors. 36 equal to 3 into 3 into 2 into 2 into 1. And for 84, 7 into 3 into 2 into 2 into 1. Now let's circle the common factors. 3, 3, 2, 2, another 2, 2, and 1, 1. Therefore, HCF equal to 3 into 2 into 2 into 1. 3 2s are 6, 6 2s are 12, 12 1s are 12. Therefore, HCF value is 12. Now let's move on to the F sum. 34. 17 2s are, 2 1s are. And now 102, 2 51s are, 3 17s are, and 17 1s are. 34 equal to 17 into 2 into 1. For 102, 2 into 3 into 17 into 1. Let's circle the common factors. 17, 17, 2, 2, 1, 1. Therefore, HCF equal to 17 into 2 into 1. 17 2s are 34, 34 1s are 34. Now let's move to the G sum. 70. Let's start with 7. 7 10s are, 5 2s are, 2 1s are. Next 105. 5 21s are, 7 3s are, 3 1s are. Next we have 175. 5 35s are, 5 7s are, and 7 1s are. Now let's write the factors. For 70 we have 7 into 5 into 2 into 1. For 105, 5 into 7 into 3 into 1. So for 175 we have 5 into 5 into 7 into 1. Now let's circle the common values. The common value should be present in all the three numbers. 5, 5, 5 and 7, 7, 7. Next 1, 1, 1. Therefore, the HCF is 5 into 7 into 1. 5 sevens are 35, 35 ones are 35. Now H sum 91. Let's start it with 7. 7 13s are 91 and 13 ones are. Next 112. 7 16s are, 2 8s are, 2 4s are, 2 2s are, 2 1s are. Finally, we have 49. 7 sevens are, next 7 ones are. Let's write the factors. 91 equal to 7 into 13 into 1. 112 equal to 7 into 2 into 2 into 2 into 2 into 1. 49 equal to 7 into 7 into 1. Let's circle the common factors. 7, 1. So that's all. Therefore, HCF equal to 7 into 1. 7 ones are 7. Hence, HCF is 7. So, on observing, 1 will be the factor of all the number. Hence, 1 will be the common factor of any given numbers. Even for two prime numbers, we will have a common factor which is 1. This is a very important 1-mark question. So, let's make a note of it. Now, let's discuss the next subdivisions. Subdivision I, we have 18, 54, 81. So for 18, it is 3 6 are 18, 3 2s are and 2 1s are. So for 54, let's go ahead with 2. 2 27s are, 2 27s are, 3 9s are, 3 3s are, then 3 1s are. Next for 81, 3 27s are, 3 9s are, 3 3s are, 3 1s are. Now let's write the factors. For 18, 3 into 3 into 2 into 1. For 54, 2 into 3 into 3 into 3 into 1. For 81, 3 into 3 into 3 into 3 into 1. Now let's circle the common factors. We have 3, one more 3, and we have 1. Therefore, HCF is 3 into 3 into 1, which is 9. And the last subdivision, 12, 45, 75. Let's start with 12. 3 4s are, 2 2s are, and 2 1s are. For 45, 5 9s are, 3 3s are, and 3 1s are. For 75, we have 5 15s are, 3 5s are, and 5 1s are. Now let's write the factors. 12 equal to 3 into 2 into 2 into 1, and for 45 we have 5 into 3 into 3 into 1, and for 75 it's 5 into 3 into 5 into 1. So let's circle the common factors. We have 3 here and 1. Therefore, HCF equal to 3 into 1, which is 3. Now let's move on to the second sum. What is the HCF of two consecutive numbers, even numbers and odd numbers? So first subdivision is numbers. So what is the HCF? We are supposed to find the HCF of any two consecutive numbers. Consecutive numbers are two numbers which comes one after another. For example, 4 and 5 are consecutive numbers. 2 and 3 are consecutive numbers. 10 and 11 are consecutive numbers. So the HCF of two consecutive numbers is 1. In order to prove this, let's compare it with any example. Let's take HCF of 2 and 3. If you solve it, you will get 1. 11 and 12, the HCF will be 1. The other consecutive number, any two consecutive number which is not a prime number, let's take that and check. Let's take 14 and 15. So the HCF of these two number is also 1. So any two consecutive numbers, if we take the HCF will be 1. Let's try and see. For 2, 2 ones are, 3 ones are. For 2, 2 ones are. For 3, 3 ones are. So the HCF is 1. For 11, 11 ones are. For 12, 3 fours are, 2 twos are, and 2 ones are. So on comparing, we have common as 1. Even for 14 and 15, 7 twos are, 2 ones are. For 15, 3 fives are, 5 ones are. So on comparing, again we have the common factor as 1. Hence, for any two consecutive numbers, the HCF is 1. We have taken here 3 different examples. First example, both the numbers being prime numbers. Second example, one prime number and one composite number. And the third example is 2 composite numbers. All the 3 examples, we got the HCF as 1. Now B sum the HCF of 2 consecutive even numbers. Here we have to look for 2 consecutive even numbers. That is, for example, 4 and 6. Because 4 is an even number, after 4, the next even number is 6. 8 and 10, because after 8, the next even number is 10. So for any 2 consecutive even numbers, the HCF is 2. Let's take an example and cross-verify. HCF of 12 and 14 is 2. And we can also take 8 and 10. The HCF will be 2. Whatever example we take, if 2 consecutive even numbers are taken to calculate the HCF will be 2. So for 12 and 14, we have already solved here. On observing, the common factor is 2. For 8 and 10, 8. For 8, 2 fours are, 2 twos are, 2 ones are. For 10, 2 fives are, 5 ones are. So on observing, we have the common factor which is 2 and 1. That is 2 ones are 2. Anyways, the highest common factor is 2. Next, C sum the HCF of 2 consecutive odd numbers. That is, we are supposed to take 3 and 5, 5 and 7, 13 and 15, something like that. Any 2 consecutive odd numbers. So the HCF of 2 consecutive odd numbers is 1. Even we can verify this with few examples. HCF of 5 and 7 is 1. Also, let's take the HCF of 25 and 27, which is again 1. So in the first example, 5 and 7, both are prime numbers. So 5 ones are 5, 7 ones are 7. Obviously, the HCF is 1. For 25, 5 fives are 25, 5 ones are 5. For 27, 3 nines are, 3 threes are, next 3 ones are. So the common factor is 1. So 25 and 27 both are composite number, even though the HCF is 1. We can cross-verify this with any type of example. Hence, these 3 statements are universally true. Now let's move on to the third sum. They have given HCF of co-prime numbers 4 and 15 was found as follows by factorization. So they have given the factors of 4 and 15. Since there is no common prime factor, HCF of 4 and 15 is 0. So they are saying like the HCF of 4 and 15 is 0, and they are asking whether the answer is correct, and if not, what is the correct HCF. Let's check it by solving. For 4, we will solve it like 2 twos are 4, 2 ones are 2. For 15, 3 5s are, 5 1s are. Now let's write the factors. For 4, it is 2 into 2 into 1. For 15, we will have 3 into 5 into 1. Hence, on observing, we have the common factor as 1. But they have given it as 0. So, no, the answer is not correct. They are also asking us the correct HCF. Therefore, the correct HCF, therefore the correct answer is 1. As I have already told you that for any two numbers, though any of the factors doesn't match, the value 1 matches. So at least we will have the HCF to be 1. Hence with this, we have completed this exercise.
Thank you all for watching Smart. Grasp, explore, and win. Stay tuned for more videos.